So as promised, we come back to a bit more of a climate focus, and we will go back to reading more quotes from different authors. So European climate is very well known to depend very strongly on what happens in the North Atlantic at all time scales, on weather time scales of days to decadal, multi-decadal time scales, interannual variability, and even ice age and deglacial, glacial time scales. The circulation here is unique in the current configuration for the last many million years, that the Gulf Stream brings warm tropical waters and extends as North Atlantic drift into Norwegian current, and then splits off and comes back here. There is the Labrador current. This warm waters create nice warm atmosphere above, which is thirsty. Warm atmosphere can hold more moisture, so evaporation goes up because the winds here are very gusty as well, especially on the Labrador Sea and between Iceland and Greenland, which create a lot of evaporation and create deep waters. The North Atlantic deep water form here in the Greenland, Iceland, Norwegian seas or Jin seas and the Labrador Basin. There are other currents like the East Greenland current and so on here. This is the southern polar gyre and the subtropical gyre. So these are strong westerly winds in certain phases of the North Atlantic oscillation, which is the oscillation between the Icelandic low and the Azores high. So depending on whether the NAO is strong, positive or negative, westerly winds can go more north or more south, and precipitation regimes and winter climate over parts of Europe will be dramatically different based on the phase of the Atlantic, and if we compare temperatures over here on the western side to this side, this winters here in general are milder, drizzly, boring climate, whereas here it can be harsh, cold, icy, snowy winters. On this side, temperature differences in the air can be order tenths of degrees and so on. Okay, so let's look at reconstructed average European June to August temperature anomalies over the period of 1 to 2000, year 1 to 2003 by Lurebacher in the next slide, together with instrumental mean June to August temperature anomalies for Europe during 1850 to 2019, when we have data, recorded instrumental data. All anomalies are with respect to the base period of 1961 to 1990, and in B we'll look at distribution of reconstructed June to August temperature anomalies with respect to the mean of the study period of 700 to 1815 over the 10th century, warmest century of the medieval warm period, also known as medieval climate anomaly, the 17th century, which was the coldest century of the Little Ice Age, and the 18th century, which is being close to the long-term mean used as the base period here. Okay, so here we are, anomalies in degrees centigrade with respect to the 1961 to 1990 common era. And here we are with the Roman warm period we had seen before, with the temperature distribution that it's got a warm tail here compared to the cold tail, and the migration period where a cooling happened and Roman Empire began to decline, trading patterns changed. We had talked about this in the context of the Middle East as well. And then we come into the medieval warm period where the temperature got warm enough that parts of Greenland allowed agriculture, and the Vikings ventured all the way there, and from that base they ventured into Northern America as well, well before Columbus landed much further south and gets credit for discovering the New World. Little Ice Age came along, as we said before. Medieval warm period ended potentially because of some elevated volcanic activities, and then came the Maunder minimum and Sporer minimum and so on, where sunspots were at their minimum, which means energy from the sun is also at its minimum. Remember, sunspots create these knots in the magnetic field, so there are dark spots, but around that form what are called plage, where radiation energy is much higher. So more the sunspots, more the energy. If you have sunspot minima, then you get less energy, which kind of helps with the little ice age, which had an impact on monsoons and other places as well, but was heavily centered on Europe. And there are infinite number of documentations of the little ice age in terms of paintings and so on in Europe. Obviously that would have affected agricultural productivity and so on, and Britain, which used to make wine, had to give it up and move to beer. Now they make good beer, and wine production now mostly happens in the south in France, and Germans make some good Riesling, but French may not agree about how good the German wine is. And here we are since the Industrial Revolution, ups and downs, and since the 1970s we've been basically warming pretty rapidly and monotonically. So the 17th century, which was the peak of the cold little ice age, shows a clear negative tail here with far fewer frequencies of warm temperatures, and in the 18th century we shift back towards the baseline that we can see here as a long-term or as the average of 1961 to 1990 Common Era. Okay. This was extended further using so-called modern analog technique and combining various pollen and other evidences to look at forest cover changes in these regions of Europe. So the study area here is divided into 8 regions to provide regional summaries of forest cover changes. Boreal region, British Isles, Eastern European region, Central European region, the Alpine region here. This is the Atlantic region. The Dinaro-Carpathian region is 7, and the Mediterranean region is 8. Mediterranean climate has been a big story as well. Even before, for example, 6 million years ago, there's a mountain of salt found at the bottom of the Mediterranean because the exchange with Atlantic probably got shut off, and this inland sea, which is a evaporative basin, can produce salt, and it's compensated by the exchanges with the Atlantic. So if you cut off that exchange, it probably kept evaporating and produced mountains of salt. And we talked about how winter precipitation over the Mediterranean region may have been part of the story of how Sahara got greened coming out of the Holocene. This is just a run through the percentage forest cover in various time slices of the Holocene. It's based on the modern analog technique, or MAT. So this is showing for selected time slices the MAT reconstructed forest cover. Gray crosses, so you can find gray crosses somewhere here, hard to see in the way I scaled them. They show pollen site locations. Light gray areas over northern Europe and Scotland represent early Holocene ice cover. So some early Holocene ice cover over there, northern Scotland. No, over here. Okay, make sure I'm in the right place. Okay, dark gray areas are excluded from the analysis due to low site density. So just to go through the periods, climate versus forest cover, we know that we were still coming out of the last ice age. This was a warming period just before the Younger Dryas, so forest cover is much less, so you can see large parts of it are not covered in forest. By 11 kiloyear we are past the Younger Dryas, which happened about 11,200 years ago, and we were into the Holocene warming, so forest cover has expanded. By 10 kiloyear, again the ecotones have changed quite a bit, extending deeper into this region here. By 9 kiloyear, thicker coverage, as you can infer from the darker colors. And by 8 kiloyear, before the or just after the 8250 event, which was a minor cooling, you can see some changes as well in these regions. 7 kiloyear, maybe darker colors over here. 6 kiloyears, much expanded darker color. Came then the cooler, drier period, so you can see the reductions in density of forests. Recovers around 3 kiloyears to 2 kiloyears. It has shrunk again over these regions, and by 1 kiloyear it is much reduced. Of course, by then agricultural societies were well set in the millennium here, so we don't know how much of it was natural versus how much of it would have been clearing for agriculture and so on. During this period also there was reforestation episodes when Black Plague caused many million deaths, and agricultural lands were abandoned, and reforestation, carbon drawdown happened, which are recorded in carbon measurements as noted by Bill Ruddiman, for example. To the Viking story, we can look at the modern day climate and how it is related to the North Atlantic oscillation we mentioned before, the pressure oscillation between Icelandic low and Azores high, and how it affects precipitation over Greenland into North America and Iceland. So we're looking at summer precipitation versus NAO index. Obviously there is a strong relation, and if you look at NAO index and annual mean precipitation versus JJA mean precipitations, NAO in the southern Greenland is and its connection to summer precipitation June, July, August. Spatial correlation between summer NAO and precipitation from 1950 to 2020. Dashed lines include areas of significant correlation here with high significance. Precipitation data are based on blah blah blah. I won't read into that. B is the correlation between summer NAO and measured precipitation from Norswak weather station over 1961 to 2020. Again, significant correlation numbers you can see here, statistically significant. The red line is the linear fit, so the regression line, and shaded areas represent 95% confidence interval. In C, we are looking at time series of the annual mean and JJA mean North Atlantic index plotted from 1950 to 2020. Brown columns correspond to corresponding to brown squares in B here. Indicate recently observed and documented summer droughts that led to a notable decrease in grass crop and hay production. NAO index in all figures accepted from this site or CPC NOAA. So does this provide some ways to think about Vikings? Well, maybe. So if we look at the reconstructed climate conditions from southern Greenland and Norse diet transition over this period from about year 400 to 2010 or so, we can see that the inferred summer water temperatures from southern Greenland, and there is a cooling happening with the Norse diet shift happening over here, and the drying trend is seen here. So we had already passed the peak medieval climate warm period by the 10th century, and we were getting into the Little Ice Age by the 11th 12th centuries. So leaf wax hydrogen isotope inferred relative humidity changes from southern Greenland show the drying trend here. Blue shading represent the 90% confidence interval. The thick blue line represents the 5-point running mean. Percentage of marine sourced food in the Norse diet is shown here in D. Okay, those are together. The ratio of marine to terrestrial mammal bones, number of identified specimens, NISP, from a Norse farm in Kasjarsuk. I have no idea how they pronounce it. Orange bar indicates the time span of the Norse settlement. Okay, so the Norse made settlements in Greenland, and they tried to survive by shifting to more marine based diet to deal with the drying and drop in agriculture, but obviously in the end they got wiped out or left. Okay, so that's a good example of how European climate also has gone through fairly significant changes during the Holocene, and we'll come back and read a few more book quotes from the chapter to look at some more complications of interpreting climate connections to humans and agriculture, to just get a sense of how physical climate scientists use proxies and then try to make linear connections to known archaeological evidences and so on. Anthropologists tend to always caution that things are much more complicated, and they look at how societal structures change before some declines or so-called collapses happen, and the time lag between climate perturbations, societal reorganizations, and declines, resilience losses, and so on. So these are good lessons to learn from different disciplines. Okay, I just wanted to correct a little bit what I said. SPG is the subpolar gyre and STG is the subtropical gyre, which I should know, but somehow while recording it I said southern polar gyre. I don't know where that came from. So subpolar gyre and subtropical gyre. Okay, so westerly winds and trade winds together form the subtropical gyre, and the mid-latitude westerlies and polar easterlies together form the subpolar gyre. Okay, let me leave it there.